Hey everyone, Mrs. Slauson. So 2 things to do today. The first one is we are just going to review one more time how do we expand and condense, because when we see each other next week we're going to work this in with solving. So the 2 things we're going to be doing today in class are going to be getting us ready for solving next week, and then on Monday we should be wrapping up the chapter. Well, Monday going into Tuesday a little bit. So anyway, let's go ahead and get started. So you should be looking at the yellow assignment. It says week 14, expanding condensing logs. I'm going to do a few problems on each side. So the front side is we're going to be expanding. So when we're done with the front, they're going to look like the problems on the back. And then when we're done with the back, they're going to look like the problems on the front. And so I've circled a couple problems to get started with you. And then what I'm going to suggest you do is you pause the video after I do some examples on the front side and then finish the front side before you go on to the back. So a couple problems I've picked is, not in any particular order, but let's just start with number 2. So remember, if there is not a base, there's an understood base of 10. So quite a few of these actually have an understood base of 10. Really doesn't matter what type of base is on the log. What we want to focus on the fact that behind it is a divided by b. And if you remember, our division is going to turn into subtraction. And then everything separated by an addition subtraction sign is going to get the log that I'm covering up put back in front of it. So if you see division, remember it turns into subtraction. So this A is going to get a log in front of it. There goes the subtraction sign. And this B is going to get a log in front of it. And now I have what they call expanded the log. So the next one I want to talk about is what if you see multiplication. So again, just ignoring this log, I see 2 times x cubed times y. Whenever you see multiplication, then we're going to turn it into addition. And then these 3 terms will all get this log that I've ignored. So a log will go in front of that 2, and a log will go in front of this. But the other rule, which I'm going to introduce as I'm doing this one, is when you have an exponent, so I'm going to use my pencil right now, it's going to start there, but then it's just going to move in front of its own particular log. So now I'm going to erase that. And then I'm going to put the log with the y. So again, if you see division, it becomes subtraction, and if you see multiplication, it becomes addition. So the final one I want to talk about with you is, for instance, number 1. There's not a rule with radicals. So what we're going to do is we're going to rewrite this problem. So it's a rational exponent. An exponent, that's a fraction. And a cubed root is the same as a 1/3 power. So that's the first big rule I want to review with you, because down on 3 you're going to see a square root, which is like a 1/2 power, and then that square root's popping up in here again. So just remember, any exponent just moves to the front of its particular log, and then it turns into multiplication. So that's a little bit on the front. What I'd like for you to do now is pause the video and finish the front. And just to point out, this is 9 times y to the 5th, 25 divided by 4 to the v to the 4th, and 4 times x to the 1/2 power technically. Okay? So now that we're on the back, what we're going to do is we're going to condense them. So instead of having several logs, we're going to condense them back into 1 log. And so I'll pick a few problems to do with you. So for instance, we can do 10, and we can do 11, and we've got a lot of subtraction on this page. Let's change a few of these. Let's change 13 right here. Let's change it from subtraction into addition. So that's just a quick change we're going to do. Okay, so we'll do these 3 problems together, and then I'll let you finish the back. So let's just start with this one. So what I'm going to do first is what I would have done last on the other page. And what I ended up doing last was, after I got it all expanded with the addition and subtraction, I took those exponents and just moved them in front of their log. So what I'll do here is whatever's in front of the log, I'll just move back as an exponent. So the 2 is going to move right back there, so x squared, and the 4 is going to move right back behind the y and become y to the 4th. Okay, so they're not here anymore. I'll scribble those out. And now I'm just going to ignore that log base 8. That'll come back later. And when I see x squared plus y to the fourth, now I'm going to do what I did on the other side, and it's going to become x squared times y to the fourth, which they wouldn't typically put that times sign, they would just smush them together like this. And now that log that I was ignoring with its base will move in front, and if you want to put this in parentheses, you can. You don't need to though. And now I've gone from 2 logs down to 1. So let's not do 13 together. I just wanted to fix that one. Let's do 12 together instead. So again, what I'm going to do is take anything that's in front of a log and just move it back as an exponent. And ignoring that ln, that natural log, which has an understood base of e, right? These are gone. I see x to the fourth minus y to the eighth, and that subtraction is going to turn into division, like that. And now, we typically don't see it with the division sign, we see it as a fraction bar. And that ln, that natural log that I've ignored, I'm just going to put it back and put it in the front. And again, if you want to put this in parentheses, you can. You don't need to. But what you won't do is put an ln with the top and with the bottom. There's just one ln kind of off to the side. So this one's done, just like this one was done. And the last one I want to do with you is number 10. So again, the 1/2 is multiplying. It's just going to move back to its log. It's not there anymore. And ignoring the log, which has that understood base of 10, it's u minus v to the 1/2, which become u over v to the 1/2. And now you can bring that log back. You can leave it like this, put it in parentheses, or if you want to go one step further, you could take that v and just make it a square root of v. So either, sorry, you can't see that, either of these is fine. It's whatever you're more comfortable with. So this one or this one. So now what I want you to do is to finish this side. And we did do 13. I changed 13 to a plus. All right, but the rest should be pretty simple as far as this goes. So that is the yellow page. The next video is going to be on solving.